Hi there, thanks for joining us on Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley. Coming up on this episode, it is a real stinker, and we'll tell you why. Also, some. You're not supposed to make any noise yet, Fred. And also, it's the end of the year, so we'll do whatever we like. The Sombrero Galaxy, a new image or two, and it is stunning to say the least, and possible new data about dark energy that might just tip everything upside down. We'll talk about all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
It's very hard to keep Fred quiet when he's excited. Hello, Fred.
I do apologise for speaking out of shape. I keep forgetting I'm not here. I'm not here yet.
Not here till I introduce you, Professor Fred Watson, astronomer at large.
Oh, thank you. That'll do. Yeah.
Nice to see you. Nice to see you. It's our second to last episode of the year officially. We will be doing some archival episodes over the Christmas New Year period, probably some that people haven't heard in a very long time. It's I don't know whether it's a good or a bad thing that we've been going long enough to have archives. That's the part. That's the part that stuns me.
That's fair enough. That's fair.
So yeah, but they're really good episodes, and what we're going to do, just to keep them a bit fresher, is tag them with a little bit of astronomical news as it happens over the Christmas New Year period. I'm leaving that up to Hugh in the studio. We finally found him a job. But yes, that's what.
Well, you see, there is a job there because if you've got an archive, you've got to have an archivist.
Yes,
somebody who looks after the archive. And I'm not going to give anything away here, but Marnie and I have a really good friend who is the archivist to a former prime minister. And she is still very, very busy with things that concerned, his prime ministership and ongoing stuff. It's really
how about that? Yeah, gosh. Yeah, over my 40 years in radio, I got to meet a lot of people with really fascinating jobs. I remember doing an interview with a fellow from Dubbo who was a tennis coach, and he was appointed. You don't think about this sort of thing happening in Dubbo, but he was appointed to be the Davis Cup coach for India. Wow. Yeah. It was really fascinating. Yeah. You just never know what's going to pop up. Never know.
You don't. That's correct.
Now, we have some stories to tell in this second last episode of the year, and the first one's a real stinker involving the International Space Station, or at least a transport spacecraft that's arrived there. Recently, we talked about that weird sound coming from the Boeing Starliner, which ended up meaning it was, they thought it was feedback, but there's been a few other theories. Now it's a rather stinky situation, quite literally, Fred.
Yes, it is. So this is a supply ship, a Russian supply ship. It's a Progress 90 spacecraft, which docked with the International Space Station on the 23rd of November, just a few days ago, as we're speaking now. And it's a completely routine process. The supply ship arrives, you open the hatches, do the airlock stuff, and you
take out all the packets of M&Ms and get on with it.
Everything. Yeah, that's right, and all the the coffee supplies and all the rest of it.
Toilet paper.
Probably, yes, that's right. Anyway, notwithstanding all that, they open the door, but they immediately have to shut it again because there's such a bad smell coming from it.
Wow.
And it's actually we might be jumping to conclusions here. It's been described as an unexpected odour. And in fact, somebody, I think one of the comments was, it smells a bit like a spray. And I assume by that, they mean, sort of like an air freshener or something like that. So it might not be a bad smell.
Right. We're just assuming that. But Yeah, well, that's why they don't allow baked beans on the International Space Station.
Sure, that's right. Yeah, I'm sure that's right. The truth about baked beans. That's right. What was that? Blazing Saddles. Yeah. So they shut the door straight away, and I should explain that the spacecraft, the International Space Station, is divided into sectors. It was made by joining together lots of modules, some of which were Russian, some of which were NASA, and the Russian spacecraft dock with the Russian side of the International Space Station. So the cosmonauts, Roscosmos scientists, and they're cosmonauts, so they're all flying. They shut the door immediately. Apparently, they also saw what are described as small droplets, but I don't know whether they were droplets in the air or droplets in, on the surfaces. But anyway, at the moment, as we speak, the door is shut. And they are apparently, and I'm quoting space.com here, the crew is not in danger and efforts to open the spacecraft are ongoing, that NASA stressed. But there is... there is, it's not, when you've got an environment like that, all the air that these people are breathing is contained in the space station. It's not a question of opening the windows to let...
I was about to say, they should open a window. Open a window, fresh, and get some fresh nothing in there.
Yes. So what you have to do is something a little bit more serious. And again, quoting from space.com, very nice article on this. After Russian cosmonauts closed the hatch, air scrubbers and contaminant sensors on the International Space Station monitored the station's atmosphere, and flight controllers said their air quality was at normal level. So it hasn't sort of spread a bad smell throughout the whole of the spacecraft. Yet, that's right. Yeah, it is a bit complex because there's doors and valves everywhere. And something I didn't know, apparently the hatch that separates the Russian side from the US side is quite often closed at the moment. And that's not...
I was going to say, people will automatically assume that's got something to do with the war in Ukraine, but it's not. It's got nothing to do with that at all.
Nothing at all. It's because the Russian side's leaking. There's an air leak. Again, everybody's stressing it's not a danger to anybody on board. But there is disagreement between NASA and Roscosmos as to what this leak is caused by and how you fix it, and whether there is a longer-term risk. If you've got a leak, you kind of worry that something's fractured or something like that, and that it might catastrophically give way, and suddenly you've got a big hole in the spacecraft.
Yeah. Apparently that leak's been going for like 5 years, though.
5 years, I know.
Oh, my goodness.
I was surprised at that too. Clearly, the International Space Station is an aging piece of equipment, obviously, it's the shining example of modern technology. But I'm always reminded of what was it? I've forgotten what the name of the construction fleet was in the Hitchhiker's Guide to the Galaxy.
Oh, the Vogon.
Vogon, that's right. It's the Vogon constructor fleet. And when the heroes got inside one of the spacecraft, it was just full of old mattresses and completely dingy, and sort of it makes you think of that sort of thing.
Was Arthur Dent, wasn't it?
Arthur Dent, yes, that's right.
Yeah. And Ford Prefect.
Yes.
Oh, gosh, I remember some trash.
Oh no, that's worth remembering.
It is. And my favourite, Slarty Bartfast.
Yeah, Slarty Bartfast. Yeah, what a name. Only Douglas Adams could think up a name like that.
Oh, he was amazing, wasn't he? Amazing. We're off track. Yeah, we're talking about the old mattresses on the ISS.
Yeah, well, it might feel like that. We were talking not very long ago, Andrew, about people just parking things on places where there's a bit of Velcro that they can stick something on, and stuff that you wouldn't expect, because there was that study done of the archaeology of the International Space Station, people photographing bits of the space station just to provide a record of what life is like on the International Space Station.
And they put all these storage systems up for certain uses and found that people were using them for completely different reasons.
For other things, that's right.
Yeah, it was quite interesting. So they don't know what the stink is. They don't know. What I understand about this supply ship is that they take all the goods out and then they fill the thing with rubbish and then they burn it up on re-entry to get rid of the rubbish. So that's...
But, if you can't get into it without a spacesuit on, it's not very nice. Yeah, that's a worry. I look forward to hearing what the cause was if they ever work it out. And if we can, we'll bring it to Space Nuts listeners.
Yes, indeed. Not something you really need going into Christmas. Could be anything. Could be anything. Hopefully it's not a bad smell. We haven't determined, what the caliber of the odor is. But, hopefully nothing nasty or noxious or anything like that. You can read that story at space.com. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Let's take a break from the show to tell you about our sponsor, Incogni, and I'll be giving you a special Space Nuts URL so you can get up to 60% off Incogni. But first, what's Incogni all about? It's a way of cleaning up your online presence and reducing the risk of your personal information being sold to unscrupulous people via the dark web or just via a hacker who's trying to fleece you or other people. It's also a great way to reduce spam emails and spam phone calls, reduce the risk of identity theft, which is big business these days. I think, most significantly, it greatly reduces your risk of being scammed. And that is just such a viral thing that's happening around the world at the moment. So how does all this work? Well, it's simple. All you have to do is sign up to Incogni, give them permission to act on your behalf, and they'll do the rest. They'll trawl the internet and remove your personal information from the web, the stuff that can be found on search engines, public websites, even private databases. It's all easily accessible, and let's face it, are you really going to be able to clean up the entire World Wide Web of your personal information by yourself? Right now, Incogni is offering a significant discount for Space Nuts listeners, up to 60% off, and that comes with a 30-day money-back guarantee. Just go to incogni.com/spacenuts. That's INCOGNI, incogni.com/spacenuts to find out more. And they have special prices for students and graduates as well. Make your personal information much harder to find online with Incogni. Check out all their plans today at incogni.com/spacenuts. Now, back to the show.
3, 2, 1.
Space Nuts.
Now, Fred, we head out a little way from our own galaxy to a wonderful place called the Sombrero Galaxy, M104 to be official. And James Webb has just taken a marvellous mid-infrared image of it that has got a lot of people very excited.
It has, yeah. And this is the thing about the Webb telescope. It just blows you away with everything new that comes from it because we're seeing familiar objects in a completely new light, infrared lights to be exact. So just to paint the picture, you said M104, M is for Messier, a French astronomer of the 18th, I think, late 18th century, who was interested in comets, and he could see all these other fuzzy patches in the sky, so he just numbered them. And these are mostly galaxies. He didn't know that's what they were, but that's what we find. So M104, normally known as the Sombrero Galaxy, because that's what it looks like. It's got a prominent dusty ring around it and a very bright and very extended core, so that the central region, looks like the top of a hat, and the outer ring looks like the rim of the hat. But with the MIRI view, and MIRI is the mid-infrared instrument on the James Webb Telescope, the core, which is made of stars, that extended core, the sort of bowl of the hat, if I can put it that way, it vanishes completely. And we see the ring itself in glorious detail. I think there are actually two rings, because there's a ring very near the center of the galaxy, and but this outer ring, which is very, very dusty, and that's why it shows up so well in mid-infrared. Remember, mid-infrared light, the dust is opaque, and you can actually see the dust directly. Near infrared, the light penetrates the dust. So what has excited people is detail in this ring that has never been seen before. And it's the scientists, and some of them are a number among my friends who look at this kind of thing, dusty regions in galaxies. They are excited to see that it's very clumpy on a scale of detail that, as I said, hasn't been seen before. And when you look at the image, you can see that this ring is made up of myriads of tiny clumps of dust. Now, the spectroscopic instrument, part of MIRI, the infrared detector, has provided evidence of polycyclic aromatic hydrocarbons.
Wow, that's a coincidence, Fred, because I believe that's what they're smelling on the International Space Station.
It might be, yeah, it might be. It depends how aromatic they are. They might be a bit unaromatic. They might want to kiss. But yeah, polycyclic aromatic hydrocarbons, a class of organic molecules, carbon-containing, and the sort of thing that we think of as going into young solar systems. That they demonstrate that there's probably star-forming regions embedded in the disk of the galaxy. Sombrero it's not one of these galaxies that's rapidly forming stars. It's what you might call a quiescent galaxy. It is forming stars, but it's at a slow rate. It's at about half the rate that our own galaxy is forming stars, which is roughly two stars per year, roughly. Very roughly.
I think I know why. The Sombrero's slightly dipped, so I think this galaxy's having a siesta.
There you go.
That would be the official scientific reason.
That probably would be. Look, I like that. I like that terminology. It's the siesta time of the Sombrero Galaxy. Lovely.
Good bet. Yeah.
And indeed, it is slightly dipped in the sky. So it does have a black hole, supermassive black hole, something like 9 billion solar masses, much, much bigger than the black hole at the center of our own galaxy. And it is active. So it's what we call an AGN, an active galactic nucleus, which is something that is, it's having a polite and well-behaved meal of material that's falling into it from its surroundings, rather than a quasar, which is absolutely gobbling everything up and radiating energy at a great rate because of that. So, yes, a low luminosity.
I think they describe this one as docile, if that can be.
I think that's probably the word I was looking for, Andrew. Yeah, docile. It's a low luminosity active galactic nucleus. Sombrero has always been interesting, though, and this goes back to beautiful images of the Sombrero that were made by my colleague David Malin back in the 1980s, the first time we saw these galaxies in color, along with many other nebulae. He was the person who put true color into astronomical imaging by using a 3-color photographic technique. His image of the Sombrero is perhaps one of the iconic images of the galaxy. But what it did show was that the Sombrero is very rich in globular clusters. These sort of more or less spherical clusters of hundreds of thousands of stars. There are about 2,000 of them surrounding the Sombrero Galaxy. We have less than 200, I think. It's about 160, if I remember rightly, globular clusters in the outskirts of our own galaxy. But the Sombrero is much, much richer. And, of course, it's near enough. It's 30 million light years away. That's pretty well on our doorstep, which is why we get such good images of it. Yeah. It's near enough that we can study those globular clusters in detail. And globular clusters are they're one of the puzzling things in our understanding of the universe. Are they the nuclei of galaxies that have been stripped of their outer stars by interactions with other galaxies, or were they formed like that as globular clusters in the earliest history of the universe? There was quite a lot of discussion on that topic actually at our 50th anniversary symposium for the Anglo-Australian Telescope. It was an interesting session on globular clusters and what we can learn from them.
Judy and I have got a lot of experience with globular clusters. Every Tuesday we babysit the grandchildren. You get a lot of globular clusters there.
I bet there are, yeah. If you've got 2,000 of them, though, then you're in real trouble.
Oh, I think they managed that.
Yeah. Yeah, so look, there's just more to come. It's a reminder of how prolific the James Webb Telescope is. Its fourth year of science operations will start in the middle of next year, next July.
Wow.
They've already had a record-breaking number of proposals for time on that during that fourth period. The deadline for submissions for observations was 15th of October, and it's an oversubscribed instrument. That a request. I love this. A request for 78,000 hours of observing time, which is 9 times more than there is available. That's what we call an oversubscription rate. We used to get oversubscription rates of 2 or 3 and sometimes 4 on the Anglo-Australian Telescope. People want, for every one night on it, there's 4 people wanting to use it. But 9 to 1 is quite extraordinary. And it speaks of just the excellence of the data that are coming from the James Webb Telescope.
I suppose that means, Fred, if they've got a record number of proposals put to them for time on the James Webb Space Telescope, they're going to have to sit down and hand pick who gets to use it and who gets to miss out.
Yes, that's the job of time allocation committees. That's exactly what they do. And I think every telescope in the world has got committees like that go through them. And they're usually extremely ethical. They give time based only on scientific excellence. So the applications throughout the world, again, I would think this is true, they're anonymized, so you don't know who they've come from. They're sort of gender-free, so you don't know, what the gender of the applicant is. It's to avoid any kind of bias of any sort. And it's a fairly stringent process. I do remember talking to one of my colleagues who was sat on one of these time allocation committees, actually for the Anglo-Australian Telescope, over quite a long period. And he mentioned the occasional death threats that he got from, people who hadn't been given their time. Yeah. People who get life and soul into it. They weren't death threats so much as, fairly how can I put it? Robust criticism, that sort of thing.
Yeah, that's a nice way of putting it. Robust.
Yeah, he interpreted them as death threats.
Yes. Wow, that's extraordinary. Yes, I wouldn't have thought that of the astronomical community, Fred.
No, you wouldn't. Yeah. That's right. But if you've submitted the same application maybe 3 years in a row, and you've put your life and soul into it, and you've got students whose future depends on getting the observing time, and you don't get it, you would feel naturally very frustrated.
Oh yeah, that makes perfect sense. But I think when we were first talking about James Webb, we did talk about how that process worked and how they were going to do it to make sure that it was all above board, level playing field, no bias, But if you want to look at the pictures of the Sombrero Galaxy as taken by the James Webb Space Telescope, not surprisingly, it's at phys.org. I'm starting to feel sorry for Hubble, because whenever there's a new James Webb image, they go, "Oh, this is what Hubble took." I just don't think that's fair.
No, but it's, and of course, the Hubble's a 2.3 meter telescope. James Webb is a 6.5 meter telescope. Yeah. Astronomy sizes everything.
Yes, well, very true. But Hubble's still doing a great job. I feel sorry for Hubble.
It is. No, it's doing a fine job and still producing good science. I'm sorry I was slightly distracted there. I'm trying to pick the key to the James Webb Telescope, which has fallen on the floor, and I can't actually pick it up.
Fair enough. Phys.org if you want to check out that story about the Sombrero Galaxy and what we're learning about it. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Finally, Fred, a story that has been published only in the last few days, our time. But this one will be talked about for a long time because, again, they're suggesting that this one could rewrite what we know about the cosmos. This all centers around dark energy, and we might have to explain what that is again because it's so poorly named. But now they're starting to think that dark energy might be a finite thing. Based on this new data.
Yes, it's a very difficult thing to measure. Is the accelerated expansion of the universe, which is why we didn't know about it until 1998, when 2 groups of scientists, one in the USA and one in Australia, actually worked out that the expansion of the universe is accelerating. So a lot of thought has gone into it since then. That's 26 years ago. And the simplest interpretation is that dark energy is constant. That means that the acceleration of the universe is something that does not change over time, except by the fact that as space gets bigger, the energy content of space gets bigger, and so you've got an increased push to accelerate the expansion of the universe. So there's been a fairly consistent view, which has apparently been supported by observations, that this dark energy is constant. However, some work that's been done on basically, it's a telescope in Arizona. Actually, it's the Mail telescope, which has a camera on it, which has been used to basically study distant galaxies in great detail and look at a huge number of them. It's a very, very elegant sort of camera. They are now thinking that the dark energy is not quite constant, and it's basically that issue that is concerning those of us in the astronomy community who are interested in the future of the universe as well as its past. What it means is, and I should mention that this involves a very large number of scientists. It's a huge collaboration. Some of my colleagues here in Australia are members of this collaboration. There are 900 scientists all over the world studying these data. Now, it's a reanalysis that we've seen coming out within the last few days. This is why this is in the headlines again. It was the original data were published earlier in the year, but the new analysis has sort of confirmed it, that there is something going on that we don't understand.
That's a change. That's a big change.
So the way it works, it's an instrument called DESI, the Dark Energy Spectroscopic Instrument, which is on the Mail telescope, and that's very similar to the 2DF instrument that we have on the Anglo-Australian telescope, which did this sort of thing back in the early 2000s. But now the technology has improved to the extent that you can look at many, many more objects simultaneously. The 2DF instrument looked at 400. And now you've got many, many more than that, and seeing them in more detail spectroscopically. And with sensitive detectors that let you look back in time up to about 11 billion years before the present time. Wow. So what you're doing there is you are so basically you're mapping the universe. This is where it gets a little bit counterintuitive. The way you detect dark energy is to map the universe, to map where galaxies lie, because it's all about the way galaxies cluster that gives you the geometry of the universe, and that then gives you what its expansion rate is doing. So they've looked at these galaxies over 11 billion years, and basically it reveals that, yes, if dark energy was a constant force, and Geordie's getting excited because somebody's about to come home. If dark energy was a constant force, that map would not make sense. And what they are interpreting this mapping as telling us that the energy is weakening, that it's you've got an acceleration that is itself slowing down, even though the expansion of the universe is still accelerating, but the acceleration is slowing down because dark energy is reducing. And that means it's quite different from what we thought it was, or that we're barking up the wrong tree completely, that it's not an energy of space, that there is something totally different going on.
This could turn our whole understanding of the cosmological model upside down. They're basically... Oh, Geordie's upset by that.
No, you've hit the nail on the head there. I think the Geordie. I think that's agreement. Is that Geordie? For goodness' sake, I'm really sorry. This is what he does. Is he gets very enthusiastic. Hang on, Rudy. I do.
Oh gosh, that is so funny. Don't you reckon? You can't even find him. Oh boy. We've just got to the key moment of the story. Oh gosh, I'm going to put an asterisk on that so that I can find it later. I hope you're listening, Hugh. That's worth bottling, that one. They can't hear me because Fred uses headphones. I'd keep telling you this part of the story without him, but honestly, it's mind-blowing. It's mind-blowing. Needs an expert touch, which I can't give you. Here he comes. There he comes.
Sorry about that. So we might have to cut that bit out. I do apologise.
Oh, no, that's all right. He'll probably leave it in.
It just goes mad. Apparently there's another dog around, which...
Oh, well, that'll do it. That'll do it. Mm. So we were talking about what this means for our understanding of the standard cosmological model.
Yeah, we were. And it obviously means that dogs are going to bark louder and longer than they ever have done before because it's such an astonishing result. Yeah, so what it means is it's going to be an ongoing story. We will hear more about this over the next few months, probably, and hopefully we will have some sort of what you might call a consensus coming up. Something that that will allow the theoretical astronomers who build models of all this stuff to try and get their heads around what might be happening with this apparent reduction of the acceleration rate over time.
Well, yeah, it's one of the big mysteries, and it's something that we get asked about quite often for Q&A episodes, and it's something that keeps coming up, and they keep testing Einstein's theory of general relativity to see if they can break it. There's so much at stake in terms of this kind of data and studying dark energy and finding out what it is and what it's doing and why it's there and how it works, all of which we don't really understand.
No, I mean, you've hit the nail on the head, Andrew, in the sense that this could be an indication of new physics that we don't yet understand going on in the universe. And that's where things get really exciting because we rewrite the textbooks on levels of that sort of thing.
Yes. And, and that leads to dogs and cats living together and all sorts of terrible things. Maybe not, but yeah.
No.
Yeah, indeed. But it's a fascinating story, very much worth reading, and I'm sure it will spawn multiple questions for us to deal with in the next a series of episodes in 2025. You can read that story in phys.org. The dark energy pushing our universe apart may not be what it seems, scientists say. That's the title of the piece. We are just about done, Fred. Thank you so much.
Pleasure, as always. And we'll speak again soon, I hope.
Yes, very soon, probably, for our final episode of the year. Thanks, Fred. Professor Fred Watson, astronomer at large. And thanks to Hugh in the studio, who couldn't be with us because he was dealing with a dark matter. Boom, boom. And from me, Andrew Dunkley. Oh, by the way, don't forget to visit our website and our social media platforms and leave reviews on your podcasting platforms if you don't mind. Reviews are always very helpful to spread the word. But for now, thank you, and we'll see you again on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.